Hello and welcome everyone to the Varsity Tutors Space Club series, where we think Neil Armstrong was being a little modest when he said that what he did was one small step for man. We're going to learn all about that today, all of the things that happened in that famous Apollo 11 mission to land Neil Armstrong and Buzz Aldrin safely on the moon. It was more than just a simple step. In fact, it almost didn't happen. And we are thrilled to have with us Greg and Chris from the Armstrong Air and Space Center in Ohio to tell us all about those events that transpired and why the moon landing is probably even more amazing than any of us even realized. Now, before I turn it over to them, I want to tell you a little bit about our mission control here, the classroom that you're in. Just like the astronauts were in constant communication with each other and with mission control in Houston, we want you to be in touch with our presenters today. So use the chat box to the right, one, to answer their questions. They've got a bunch of questions to help put you in the driver's seat or pilot seat, so to speak, and see what kind of decisions you would have made if you were in Michael Collins, Neil Armstrong, or Buzz Aldrin's shoes during that day. We also want you to ask questions. So any questions you have at any point during the class, drop those in the chat. And in the last 10 minutes or so, I'll interview our experts with your questions and we can get you some answers. One last thing, make sure you've got a camera nearby. Did you know that actually digital camera technology was developed for the space program so that they could send back all those amazing images from all the far reaches of space? So let's celebrate that. Have a camera nearby, and in about a half an hour, we're going to give everyone an opportunity to lean into the screen, take a space selfie with the crew of Apollo 11, and if you upload that to Instagram after class and tag Varsity Tutors and the Armstrong Air and Space Museum, you'll have an opportunity to win. You'll be entered to win a copy of First Man, the biography of Neil Armstrong's life, which we'll show you here in just a second, and an enrollment in Varsity Tutors Space Camp for this summer, where you can geek out on even more space exploration things. So a lot of reasons to take that picture and get it up on Instagram. I'll have all the rules and everything up on a slide for you at the end. But with that said, I think we are cleared for launch. And so I want to turn it over first to Chris Moynihan and our friends at the Armstrong Air and Space Museum. We're clear for liftoff.
All right. Well, hey, Brian, thanks for turning it over to me there. I'm going to start my share here of my screen. There we go. So my name's Chris, and I'm the Director of Education Guest Experience here at the Armstrong Air and Space Museum. We'll be joined a little bit later by Greg, and he's our experience coordinator here at the museum. But we're going to talk about that critical mission on Apollo 11, how it almost did not happen, and what challenges the astronauts had to face. And maybe if someday you want to become an astronaut, some of the challenges that you'll face. But first, let's start off with a question. Why do you think they would want to build a museum to honor Neil Armstrong in Waukesha, Ohio? So we'll start off. You should look on the right-hand side of your screen there. If you could type in your answer there. Why do you think they want to put a museum here in Waukesha, Ohio, for Neil Armstrong? So I'll give you a few minutes to do that. Start to see some answers come in over there. Okay. Well, maybe. And that's actually yep, we got a correct one there. So we'll go ahead and move on there to that. But they wanted to build a museum in Waukesha, Ohio, because one is the birthplace of Neil Armstrong. He was born in Mullen Township on the outside of Waukesha, Ohio, between here and New Knoxville, another small town. But they also wanted to honor all of the astronauts in the space program at that time. So Governor Rhodes proposed a museum be built. And guess what? He said, if we put up some money and the town were to put up some money, maybe we can make it happen. And they did, and they made it happen. So you have the museum there, and there's a picture of the museum. And here's another question for you. So I'm going to be throwing some questions at you right away, and Greg's going to have a lot because you're part of mission control tonight. So you got a lot of questions to go through. But if you look at that screen there, you'll kind of notice that there's a dome shape and there's an outside. Why do you think they would want to build the museum to look like that? So why do you think the structure has a dome on it? So go ahead and you can type in your answer on your right-hand side there. And I'm starting to see some of them come in there. Okay. Dome, they wanted to, okay. And that's actually true. I saw that they wanted to actually bring in the sun's energy. Some people think, well, that's a moon. Well, that's not actually a moon, or that's not actually a golf ball on a hill or something rising from the hill there. That's actually built to be a dome. So you'd have to have a dome structure that would harvest the sun's light for the plants and animals to grow. And then you would also, on the outside, it kind of looks like wings coming away from the dome. That would be the bunkers where the people would stay. And then that long pathway leading up to the museum there, well, at night, that's lit up to look like a runway. So it actually looks like the plane at the end there is taking off. This is an old version of the photo when it was originally built in the 1970s. Now, inside the museum, what you would see is some different artifacts. If you joined us in March, you would have learned all about the Gemini 8 capsule. So there's a picture of the Gemini 8 capsule there. We also have an actual lunar sample. So that's a lunar sample or a moon rock that was picked up during Apollo 11 moon landing by astronaut Neil Armstrong or Buzz Aldrin. So it's one of those that rock was picked up by that team during that time. Very neat. And then you also have some space suits there. That was one of Neil's training suits. That suit weighs 193 pounds on Earth, much less though on the surface of the moon. Only about 32 pounds. If you're curious as how much you would weigh on the moon, you take your weight on Earth and divide that number by 6, and that's how much you would weigh on the surface of the moon. So pretty cool there for some of the artifacts that you would see. Among other things that we have planes, and you'll probably see some artifacts below me. Greg's going to be talking about those a little bit later as well, and they're going to be part of our mission tonight. And we already talked a little bit about the unique design of the museum, but here's another question for you. Why do you want to make it look like a moon base? So go ahead and you can type your answer in off to the side there. And as they start to come in, so now we know, well, they wanted to make it look like a moon base, but why? So what's the whole purpose of that? Okay. Ooh, it looks like a lot. Oh, there you go. It looks like a lot of you have put in some of the good answers there. Basically, they thought we were going to be going to the moon. And they said, you know what? We're going to have bases there. We're going to have a lot of stuff there. So this is what a moon base would look like. Unfortunately, though, we haven't been back to the moon with people since 1972. So kind of a bummer for us, but you guys could be the potential group that gets us back there and maybe one day to Mars if you wanted to take that mission. But now let's talk about this mission, Apollo 11, and how it succeeded in putting 2 American astronauts on the moon. Now, here's the kicker for this. When you have the moon landing and you have the astronauts going, there's quite a few things that they have to do and obstacles that they have to overcome, but mission control also has obstacles as well. What happens if they would have not landed safely? It's basically the matter of a flip of a coin. They did not know if they were going to encounter problems, if they were going to be able to land, and then, strikingly, after they land, would they be able to take off? So that's one that some of the astronauts, they did not know what problems they might face, and they didn't know if they were going to come back. So it was a real wake-up call for the program and a real challenge on what they had to do to come home safely and what they had to face to make that happen. So tonight, Greg's going to be talking to you a little bit about the moon landing itself, but when he's talking to you, he might be using words like limb. And if he says limb, I got an arrow pointing to the limb there, and there's a model below me. He'll be showing you that, but that's where the astronauts lived. And it's a very small area, enough for about 2 astronauts. You could probably fit more people in there, but very small. Imagine the size of a small bathroom. Not very much space that they had in the limb. Basically, it was just basic living quarters, because while they were on the moon, they would only be on the moon for a couple of hours. They would have a sleep period. They would be outside the spacecraft at that point too. So they really didn't want to have too much like a base until later flights or later missions is what they were thinking, because the real goal was, can we land and can we come home safely with Apollo 11? And just to put this in perspective for you, now I'm not going to insult your intelligence there. You guys could read through that if you like, but this is the actual wording that was given to the president, and actually what President Nixon would have read had the astronauts been basically forevermore to stay on the moon. Basically, they said it was the matter of a flip of a coin. They're taking these brave men, no hope of recovery, so they're sacrificing their lives to stay on the moon. Had there been a disaster that they had to stay on the moon, that they weren't able to take off later from the limb, because that was the only part that did not have a backup, was actually taking off from the spacecraft, and Greg's going to explain that a little bit later. So they didn't know if they were going to be forever destined to remain on the moon. So it was, again, the flip of a coin. And they had a speech ready just in case. And this speech was prepared right before they left. So they knew, and the guys knew too when they were taking off, and people at NASA knew, it might not happen. But it did happen because they were able to solve problems correctly, and they worked together with Mission Control to make that happen. So can you guys do the same thing tonight? Now I'm going to be turning over to Greg. He's our experienced coordinator. He's going to be going into what that entailed and then be testing your knowledge to see if you guys could pass that mission successfully. So Greg, if you'd like to come on in here.
All right, so thanks for allowing us to be here and to be participating with you tonight. And so we're going to talk about the mission to land on the moon. So what is it we have to do? Well, we have to be able to go to the moon, then we have to be able to go into orbit around the moon, and this is called lunar orbit insertion. May sound like a fancy word, but it just means going into orbit around the moon. This is what has to happen before we try to land. Now on Apollo 11, this basically was made up of two separate engine burns, but we're not really going to worry too much about those. These, once they burned that engine and actually slowed down a little bit, this placed the command and service module and the lunar module, both of them together, and we'll see a picture of that, into orbit around the moon. Then we have two phases of landing. We have the descent orbit initiation, which is another burn by the engine, and then we have powered descent initiation. Okay, so we've got those two phases, and then in PDI, or actually in powered descent, that's burning the engine to land on the moon, we have three phases of that. We have the braking phase. Most of the time during that phase, you're slowing way down. The second phase would be the approach phase, when you're getting close to your landing spot. And then the third phase is the terminal descent phase, when you're actually really close to being able to touch down on the moon. Now, as I said, we have an image here of the lunar module and the command and service module, and they're connected together. And this was actually how it looked when it was on its way to the moon. So on the right side, you see this big cylinder, and that's the service module, and the little kind of a conical shape there in the middle, that's the command module. On the left side of the image, you have this spindly-legged, spidery-looking thing. That's the lunar module, and we're going to see a little bit more about that. So this is how the spacecraft combination would look as it went on its way to the moon. But we want to be able to get from orbit down to the surface, and so we need to separate those two spacecraft, and then the LEM, the lunar module, needs to come down and land. So in order to do that, we do this DOI. Now, the DOI, that descent orbit initiation, see that arrow there? That's where that takes place. It's a 30-second engine burn. Okay, and this creates a slightly elliptical shaped trajectory or pathway that goes clear down to the bottom of the image. And then down here we have powered descent. Okay, and this powered descent lasts about 12 minutes. From the time they do that powered descent, the engine is it's staying on, it's burning constantly, and that allows you to actually touch down safely on the lunar surface. You're essentially going from 3,600 miles per hour, that's right, 3,600 miles per hour, down to about 1 mile per hour, okay? So you gotta slow down quite a bit. So these three phases of landing I talked about, and this is the braking phase. Over here on the left, we see the spacecraft, and believe it or not, it's actually lying on its back as it's moving to your right. Okay, so it's flying sideways, and that pink arrow there is showing the direction of the engine firing. Okay, you see that? Now, if you look at this other arrow down here, this is called high gate. Don't ask me who named it and why they named it that way. That's just what they called it. And this is the start of approach phase. Okay, that's that. And then down here, you have the low gate. The low gate is just about a minute and a half until you land, and it's only about 500 feet off the ground. Okay? You notice that the spacecraft is kind of tilting upward as it gets nearer the landing spot. Now, this is a shot of the inside of the spacecraft. This is called the crew compartment inside the lunar module. Neil Armstrong and Buzz Aldrin were standing in there next to each other, and Armstrong is on the left looking out that triangular window, and Buzz Aldrin is standing on his right looking out the other window. Armstrong is actually flying the spacecraft. Buzz is the flight engineer, co-pilot, and navigator. Okay, it takes two to do this. All right, now this picture is of the attitude control assembly, that arrow there pointing to that white pistol grip there. Armstrong had a hold of this thing with his right hand. Now, if you're looking at that big boxy white thing, you wonder what that is. That's just an armrest. So this controller, and I'm going to show you another controller here in a minute, this controller allows the spacecraft to roll, to pitch, and yaw, but I will show you that in just a moment. This is what we're talking about, but what we're going to do is, after you kind of get this in your mind about these arrows that are spinning around these various axes, now what I'm going to do is have Chris stop screen sharing, and I'm going to show you with an actual model what we're talking about. Okay, so this is a model of the lunar module. Okay, it's a beautifully detailed model, actually. So it's facing you. Okay, see, it's facing you. All right, and if you're rotating the spacecraft, you might be rolling the spacecraft. Okay, this way or this way. You might be yawing the spacecraft. Notice I did not say yawn, I said yaw. Okay, so that's yaw. Okay, rotating about that vertical axis. And then pitching the spacecraft would be like this, pitching it up or pitching it down. Either way, you can call it that way. But that is a good indication of how we control the attitude or how this vehicle is oriented with respect to the lunar surface below. Okay, so again, you're just rotating it around the various axes of motion with that white pistol grip on your right. That's how you would do that. Make sure I put this down correctly. Okay, now what I want to show you is this other controller, and we'll see an image of it on the screen here in a minute, but this is an actual device that on the spacecraft was used to control another way of controlling a spacecraft, let's say, which is translation, which is moving in a straight line. So if you're moving forward, if you push this handle down in, you're moving the spacecraft forward. If you pull it out toward yourself, like this, you're moving backward. If you push it to the right, the spacecraft will move right. If you push it to the left, the spacecraft will move left. Okay, does that look kind of like common sense there? That should. That's the way it was designed. Okay, this is the controller, but for translation, not rotation. Now, the other thing real quickly is if I take this lever and move it up, I can control how much thrust the engine is making so you can slow down to land. Okay, so this is called a thrust and translation control assembly. Kind of a mouthful, but that's what that was designed for. And Armstrong would have his left hand on this. Okay, so now we can start sharing again. Okay, so now we're looking at this same thing I just showed you. This is inside the spacecraft. And as I said before, you can control the translation of the spacecraft moving in a straight line in a direction, or controlling how much thrust the engine down here has. Okay? All right, so now that's just the T handle there that I showed you. So there again, it's just translation, straight up, down, side to side, forward and backward. Now, in the spacecraft, we have a couple of instruments. We have a lot of instruments. Actually, we have a whole bunch of them. But we have a couple of them that are really important. We have the attitude gyros, or these guys that flew these spacecraft called them the 8 balls. And here's one, here's the other. So Armstrong was looking at the one on the left. Buzz was looking at the one on the right. And these tell you, remember I talked about the controllers just a minute ago and how you would control the spacecraft relative to the lunar surface. Well, those balls, depending on how they're rolling around, will tell you your attitude or which way you're pointing relative to the lunar surface. Very, very important. Now we're going to go back here and we're going to actually ask you how in the world you're going to control this spacecraft. We just talked about these controls. Now we're going to ask you to answer a question. So I've got the pictures of those up there. In the left corner, we have A. And we have B right there. And then down below on the picture to your right, we have C. So here's my question. Which one of these would you use if you wanted to control the rotation of the spacecraft while you're trying to land? The rotation. Which one would you use for rotation? A or B, or down at the bottom of that picture, C? So make your choices in your box there. Yeah, okay, let me see here. Yep. That's almost right. Yep, you're on the right track. You're on the right track. So I see where you're coming from. I can almost hear the wheels turning. Okay, so very good. Okay, so I see it. Somebody's got it. So basically, A is for rotation. Remember, we talked about that. The white pistol grip is for controlling rotation of the spacecraft. All right, so if that's the case, then B would actually be for the other thing, the other two things, really. One is translation. Again, we got to get away from thinking of that in terms of languages. We got to start thinking in terms of moving in a straight line in 3 dimensions, straight line, forward, backward, so forth. Now, I got to be honest with you. I tried to trick you a little bit. I just want to see if you're paying attention. So C down there at the bottom, that's actually the handle for the hatch. So, sorry, I just threw one out there and see if I could catch you with it, okay? Just make sure you're paying attention. So C is just the handle for the hatch. That's how they get outside, okay? So A is for rotation, B is for translation and throttle, and C is how you get out to go out on the moon surface, okay? All right, so there's B, there's A, and there's C. All right, now we're seeing a shot here of the disky. This is the display and keyboard. This is not the computer, okay? Today's computers, yeah, they're pretty small. In those days, your computer was a lot bigger. And so this is what you'd call your interface. This is how you actually give commands to the computer and how the computer tells you some of the things that it's doing. So both the command module, where Mike Collins was, and the lunar module, where Neil and Buzz were, are able to use these computers to control the spacecraft and what they needed to do. And you had to enter the commands into the computer. You would actually use 7 keystrokes before you could actually put something in there. Now, Chris mentioned this earlier. We're going to talk about the 3 challenges that these 2 men were facing when they tried to land that spacecraft on the moon. Okay, so we had a couple of different things, and we're going to talk about them in order. The first thing we're going to talk about is computer alarms. Some of you may have heard about these alarms, and we're going to talk a little bit about them. So that's one thing they had to face, and they weren't expecting it. Number 2, there were boulders in the landing spot that they weren't anticipating either. Okay, and then finally, they were getting a little low on gas. You've probably been out driving around somewhere with your parents, and maybe you ran out of gas. Well, that can be a real problem if you're trying to land a spacecraft on the moon, okay? Last thing you want to do is drop about 30 or 40 feet or more and hit the moon hard. So those 3 things we're going to talk about. So remember we talked about powered descent, and this is the 12-minute engine burn that you're going to go into when you're going to try to land. So you start your engine and you're firing it as you're coming down, and 5 minutes into that process, you see this picture here with these lit up numbers, 1202. They were about 35,000 feet from the surface of the moon, and now they're getting a computer alarm. Okay, this doesn't sound like a great thing. So now, what about if you, and I mean you, okay, all of you, you're going to be the flight director. Okay, this gentleman right here in this picture is Gene Kranz. He was the flight director on Apollo 11 during this period of time. But what about you? So if you are him, you need to make the decision to either go, that is try to land, or no go. You would need to abort. That means you need to stop trying to land and get back up there in orbit because things have developed to a dangerous point. So I don't want to put too much pressure on you, but think about this. The lives of 2 men and the success of the mission depends squarely on, that's right, you. You're in the driver's seat. You're in the hot seat, okay? So you're going to be Gene Kranz, and you're going to be stuck with making some really hard decisions. And by the way, these decisions had to be made very quickly. Didn't have a bunch of time to sit around and smoke cigarettes and eat pie and drink coffee and all that. You had to make these decisions very quickly. So Armstrong, during this process, they get this 1202 alarm, and Neil Armstrong calls down to Houston and says, we need a reading on this 1202 program alarm. Because guess what? Those 2 had never heard of it before. Okay, this is kind of a shock. They don't know what this thing is. Now, as flight director, you don't know either. You've never heard of it before either. So here's my question to you. I've got 4 choices for you. Here's what you need to do. Ask yourself, do I A, immediately tell the crew to abort? Well, this is a kind of a problem. This computer alarm came out of nowhere. What are we supposed to do? Maybe we should just abort. What about B? If you're Gene Kranz and you're focused on these guys landing, maybe you just tell them, don't worry about it, just ignore it, because nothing is as important as landing on the moon. We've got to make this happen. Or how about C? Do you tell the crew to just push pause until they can figure it out? Because after all, if you're playing video games, you can do that, right? You can play, I hit pause, I gotta go to the restroom and get a sandwich, maybe I better stop and think about this. So you push pause and you think about it. Well, these guys, did they have that kind of time? So that's another question you got to answer. Here's another one. D is your final choice. Do you ask the people in mission control that are technical experts, do you ask them, what is this? What are we supposed to do about this? Okay, maybe that's the answer. Okay, so make your selection, A, B, C, or D, and put that in the box there. Okay, waiting for, all right. Yeah, well, yes and no. That might be the case, but are you sure? Is that your final answer? Okay. Okay, so I see some of you, you're picking up on that. That's probably a good choice. Yeah, that's probably a good choice. So actually, and some of you made this choice. So D, it's always good to ask someone who knows, right? If I don't know something, I'm going to ask Chris or I'm going to ask somebody else who might know the answer. Okay. So what Gene Kranz did, not knowing the answer, he said, I need somebody in the back room who can tell me what this alarm is. So this guy on your screen, and this guy was in his late 20s at this time. Okay. Jack Garman, he was a NASA computer engineer. He had a cheat sheet. And on that cheat sheet, he had those alarms listed. So he said, yeah, we're go on that alarm. That's what he said. So you receive word from Jack Garman that, yeah, they're go on that alarm, but the responsibility is on your shoulders, not his. Okay, you've got to make that call. So here's another set of questions. Do you A, abort the landing anyway because you just don't feel that it's safe enough and you don't know Jack Garman that well? You never met him before a couple of weeks ago. Maybe he's crazy, maybe he doesn't know what he's talking about. So maybe it's too risky. So that's A. What about B? Tell the crew they're go for landing because that's what Jack said. Well, what about C? Tell the crew they should stop playing games on the computer and get serious. Maybe that's the reason that there's an alarm. These guys might be playing games on the computer. How do I know, right? So those are your choices. So go ahead and make your choice, A, B, or C, okay? All right. Yeah, I didn't throw anybody off of that. I know. But I just had to do it. I had to throw that out there just in case I could nail somebody, with it. So, okay, I think most of you are getting the idea. You guys are pretty sharp, girls, guys. You're pretty sharp. Okay, so actually, you're right. Most of you got it. B, Gene Kranz tells Capcom, Charlie Duke, Capcom is the capsule communicator. He talks to the astronauts. He says, Charlie, tell them they're go. Okay. Now, I have to say right now that there were 4 more alarms during this period of time, but they were all similar to the first one. So they went ahead and Jack Garman said, we're go. As long as we don't keep having them, just ignore them, which is nice because, man, this is the first time we're going to try to land on the moon. You don't want to have something mess it up. Okay. So there's Neil. Actually, he's going through some training there in a mock-up in one of the trainers. Now, instead of being the flight director, Gene Kranz, now you're going to be Neil Armstrong. You're going to be the commander. Will you be able to land this thing on the moon? Will you be able to do that? So during the approach phase, Neil is looking through his window, and you see that scale on the window there? That's called the landing point designator. And actually, he would get a number from the computer that Buzz would tell him, like 40 degrees or 35 degrees, and he would know where to position his eye and where to look in that scale to see out the window and on the ground the place that he's supposed to land. Okay? Well, when he does that, he's realizing that there are boulders up there. I'm supposed to land at West Crater, and there are all kinds of big, when I say boulders, I don't mean rocks this size. The size of cars is how big those boulders were. He and Buzz looked out the windows and looked at each other and said, this isn't going to work, okay? The LEM is nearing West Crater, but they can't land, okay? So I'm setting the stage for you. So here's what we got to figure out, okay? You don't want to slow down more, because if you slow down more, you're going to come down sooner, right? You want to slow down less. If you slow down less, you'll be able to keep moving beyond the boulders. So what we have here is a couple of pictures of the LEM. This one on the left, they're flying sideways, pretty much. And so you want to rotate the LEM so that the engine is pointing more downwards, not sideways, because you're just slowing down too much. You need to stop slowing down too much, okay? So instead of slowing down too much, you want to rotate the spacecraft like we see on the right and point the engine's exhaust downward more so you can slide past those boulders. Okay, so I'm going to get you with another question here. Okay, so what kind of maneuver do you need? Now think about this, process this. Okay, you want to slow down, but you want to take this exhaust and roll it underneath you more. So what do you need? Do you need do you need to translate that is moving a straight line? Do you need to B, change your attitude or rotate the spacecraft? Now this is a little tricky, folks, so stick with me here. Or do you C, change your attitude, rotate, and then translate? Or D, this might be an option. Stand on one foot and whistle the Star-Spangled Banner. Now, I know this may sound crazy, but maybe at this point you need some motivation. Maybe you just need to hear the Star-Spangled Banner because it'll make you feel better about what you're doing. Maybe it gives you a little bit of courage, okay, to make these tough decisions, all right? Or maybe it's just a nutty thing to do, all right? So A, B, C, or D, make your choice, okay? Make your choice. Okay, as we go through these things, you folks are getting sharper and sharper all the time. I think you're getting used to our presentation. So anyway, yeah, I think most of you have gotten the idea. There's a few of you that are sort of halfway there. You sort of understand what we're doing, but some of you have already got it, okay? So this is really great. You're really thinking, you're engaging your minds. Okay, yes, it is C, okay? C, and here's what Armstrong does. And I've got an arrow that you want to watch here, and the arrow is going to show you what he did. Now watch the arrow as it comes in from the right. He flies right past West Crater. He flies just a little past Little West Crater, and there you see a photo from a fairly recent shot, a picture of the moon's surface, and those white arrows are pointing to where the spacecraft actually landed. Okay, it actually landed there. So what he needs to do is rotate the spacecraft, needs to pitch up so he can avoid slowing down too soon, and this will allow the LEM to translate or move straight lines farther down the way, past the boulders, and then he can land in a safe spot. So it's a little tricky, this one, okay? We threw you kind of a curveball there, but basically you got it, okay? So very, very good. Now, finally, we talked about this a moment ago, but, running out of gas sometimes ain't so bad. If you're in town and you're not too far from your house, weather's not bad. It's not too bad. Landing on the moon, that can be a problem if you run out of gas. Okay, so this is the last major challenge that they had. They're low on propellant. Now, both the crew and the people in Houston are receiving a reading, okay, through radio waves, and they're seeing how much fuel or propellant is left aboard the Eagle, the LEM. Okay, so Armstrong and Aldrin are descending toward the surface, and they're told by Houston, you guys have 60 seconds left, meaning 60 seconds of fuel left, okay, before they run out. And then the timer keeps going, and then they're down to 40 seconds. Now, this is getting pretty hairy, okay, for people on the ground especially. You imagine, you can't see what's going on in the spacecraft. You can only hear radio traffic. Okay, so here's my question to you. If you are Gene Kranz, the flight director, here's what I want you to do. Answer this question, okay? What do you do? A, do you cover your eyes and just hope the problem goes away? Maybe you'd even feel like climbing underneath the desk. Okay, just hide, just pretend it's all okay, because this is really stressful, okay? Or what about B? Do you trust that Armstrong and Aldrin, these guys are doing what they do best? These guys know how to fly this thing. So trust them that they'll be able to land before they run out of fuel? Well, you'd like to think you could do that. What about sea? If you just tell them, look, guys, it's just too much. There's too much stress here. You just need to abort. Okay. I don't want you guys to get killed, and you don't want to get killed. So just quit. Just quit trying to land and get back up there. Go back and talk to Mikey and, come back home. So make your choice there, A, B, or C. Hopefully you can sort of see the answer already. You can sort of see that. Okay. So what did you choose? Okay. Yeah. That looks good. That looks like a couple of you have really gotten a hold of that. Well, here's a shot of the forward panel of the lunar module. And up on the top left, if you look at this arrow that pops in there, that is where they saw how much propellant they had left in percent. Now, technically, the way this worked was if you got down below 5%, then a warning light would come on. Okay. So they were getting darn close. And the people on the ground are saying, yeah, you got less than 40 seconds and the clock keeps ticking and they're still not down yet. Talk about people biting their nails and people sitting on the edge of their seat. Okay. Pretty hairy. There's the contact light. That's what goes on when you actually touch down. Well, the answer, as some of you already guessed, was B. Gene Kranz lets these guys do what they do best. His flight controllers sit there, they bite their nails, but they hang on. And they don't go crazy. And these guys allow the crew to fly the LEM and land at a surface speed of 1.7 feet per second. That is about 1 mile per hour. I don't think you could do it any better than that. Okay. So it was a perfect landing. All right. Whew. So we can all wipe our brow, Now, the tricky part was they were informed that they had less than 30 seconds when they touched down. Truth be told, they had about a minute left. But here's the thing to remember. Yes, you remember this, okay? At the time, in real time, aboard that spacecraft, these two men didn't know they had all that fuel left. Everybody thought they had less than 30 seconds. Boy, that was close. Somebody asked Neil about that later, and he said, oh, that was plenty of fuel. Well, he would say that. He would. Okay, so Apollo 11 successfully performs the first manned landing on the moon. We achieved a national goal. The crew was brought safely back to Earth. All is well. And you can see these guys at Mission Control waving the American flag because, boy, that was a great moment. And in fact, it was really better that they landed safely than they planted an American flag on the moon. That was nice, but really they were able to come back safely. That was the most perfect ending to a storybook story. Okay. So this is one of the only shots of Neil on the moon, and Buzz took this shot after they came back in, and he looks really satisfied, but boy, if you look at his eyes, I mean, they were just shot. They were just so jacked, and they had been up for so long. They were so exhausted, but what a satisfied moment. So we want to thank you so much for participating in this mission. And we are going to turn this back over to Brian, but we have I believe we're going to do the selfie.
That's right. Yeah, we want to give everybody an opportunity to take a selfie with the crew of Apollo 11, who, as we learned, and a huge thanks, as Greg mentioned, also get your questions in. So while you're searching for that camera, if you're lining it up, we're going to give everybody an opportunity. We'll turn off our cameras in a second. Give you a chance to lean in and get a picture with this crew here. Reminder, if you upload that to Instagram when you're done taking the picture and tag the Armstrong Space Center and Varsity Tutors, you'll be entered to win First Man, a great biography all about Neil Armstrong's life, and a spot in Varsity Tutors Space Camp this summer. So with that, we'll cut our cameras so you get a unobstructed view of the crew here, and then we'll be back to take all of your questions. All right. Hopefully everyone got a great picture that you can send up to Instagram. It may involve some satellite technology, so even part of you may be involved in space at that point as well. Reminder: get those up on Instagram. We'll have the official handles up there on the way out, so you know exactly who to tag. And then also, if you want to learn a little bit more about Varsity Tutor Space Camp, there's a link right there on your screen. You can click to find out more, either to hear more about your prize and the immersive week that you'll spend learning about space this summer, or to just register and not even wait to see if you've won. And we'll have winners up in the next 10 days or so. So with all of that, it's time for questions, and you guys have had some amazing ones out there. Greg, while we've got you on screen here, and I think we'll probably go back to full screen on the presenters here now as well. One question I think a lot of people have been asking over the last, we'll say 30 seconds, but maybe it was 60 seconds, is how did it get that close with fuel? Don't they plan those things out ahead of time? Did we ever find out why was it that they were allowed to get so close to the empty fuel tank and therefore a disaster?
Okay, so one of the big issues that we had with Apollo 11 and 12 was we had insufficient baffling in the propellant tanks. So they were getting an incorrect reading. They were not actually, what happened was the low propellant warning went on 36 seconds early. So they adjusted for that, and starting with Apollo 13, I believe it was, they actually put more baffles in the propellant tanks, and this stopped the propellant from sloshing quite so much, and this eliminated that problem. So they really had a minute left.
That still seems really, really close for comfort if you were, having to land there. But I guess, they calculated that. They knew where they wanted to land.
They do, because you can't take too much propellant with you, because then that's too much weight. So they actually had some dispersions between the time they entered their descent orbit and the time that they initiated powered descent. And so anytime you have any kind of dispersion at all, these things are kind of variable. So it's just one of those things that, had they not had that issue of trying to move, they had to move 1,100 feet further down range, and that burned quite a bit more propellant. So the whole Boulder thing, it's one of those incremental things. If one tiny little thing gets out of spec a little bit, then it adds incrementally down the line. So
they had a minute of insurance to make sure they could land where they wanted to land. So I think we all feel a little bit better about that. Now, we're talking about that last minute and that last 30 seconds and all those kind of things. Another question that came up quite a bit was if you could tell us about how long were the astronauts in space? How long did they spend on the moon? Can you tell us a little bit more about just sort of the overall duration there, and maybe even put into context how long that last minute was in terms of how long was the Eagle on its own? Any of those things about timing you could tell us, people really would love to know.
Okay, so the mission overall lasted just over 8 days. It takes 3 days to get to the moon from Earth. It takes 3 days to come back. And so they actually were on the moon, physically sitting on the moon, the two men, in the spacecraft for 21 and a half hours. And during that time, Michael Collins was flying the command module by himself in lunar orbit. They were only outside playing in the dirt for 2.5 hours. And again, the first time we went to the moon, our concern was not exploration, and our concern was not scientific investigation so much. It was really two objectives. One, put boots on the moon. Two, get back alive. Later missions took up the cause, and they spent a lot more time outside. But that first time, it's mostly just to get on the moon and get back. So then from not starting power descent, DOI. So when you start changing your trajectory from orbit to come down and land, it's about a half an hour from the time you deorbit to the time you touch down, roughly. But again, that last phase of the landing, which is called terminal descent, that's about 1.5 minutes. And that's not very long, And again, I want to emphasize that when you're in lunar orbit, you're moving about 3,600 miles per hour. When you touch down, you're moving 1 mile per hour. So you've got to bleed off that blossom. Yeah.
What a soft landing when you mentioned that 1 mile an hour. That's, I think if any of us jump and then go back and touch the ground, we're moving faster than that just based on gravity, right? So it's pretty amazing how perfect of a landing that was all things considered there as well. So, hey, I'm going to cheat a little bit and ask a question because we were talking a little bit about before class, and I thought that this was pretty fascinating. Can you tell us a little bit about the ladder positioning and sort of, it wasn't as easy. It was an easier landing for the Eagle than I think it was for Buzz and Neil themselves, right? Tell us a little bit about the ladder and what it took for those guys to actually get those boots on the moon.
For those of you who can see this model, I'm going to show you where the ladder is on the front of the spacecraft. So basically, if you see where the ladder, the bottom of the ladder is, and you see where the footpad is, that's about 3.5 feet. So you might wonder, why would you do that? Why would you make it so high that these guys had to jump down onto the footpad and then jump back up to make sure they could get back up there when they left? And the answer is pretty simple. It's a design issue. It has to do with the fact that we don't have a bunch of shock absorbers on these legs, and we're going to land on the moon. We don't know if we're going to be able to land really softly, so it might be kind of rough, might be kind of hard. So what the engineers at Grumman did was they put aluminum honeycomb cartridges in these legs. They're crushable. That's only one-time use. Once you crush them, that's it. But this would absorb the impact, and it would, what's called stroke. So this leg would actually go up into the housing there. So if you were not thinking about this, weren't careful, and you made the ladder go all the way down to the bottom, when that thing stroked, it would destroy half the ladder. And then the guys would have a real problem getting all the way down and getting off that ladder and trying to get back up. So the engineers were smart, and they put that ladder shorter than you would think, so that it would be compensating for that leg if it had to stroke a large amount. And that's why that ladder was so short.
That's really fascinating to think about the way, they didn't know that they would get that perfect landing that they did. So they had to build in a little bit of extra space for those legs to crunch up a little bit. That's really, really fascinating. You said it was about 22 feet in total from where the hatch was at the top of the whim for them to have to get down. Is that right?
Well, from the very top where the docking hatch is to the footpads, yeah, it's about 22 feet.
So definitely more than one small step for man. It was a pretty, long ladder descent and then a 3.5 foot jump. So Neil was being modest, like we talked about, and I think that's
well. Now here's the thing to think about. Even though he had to jump way down to the footpad, when he did step off the LEM, it literally was a tiny step because he was just moving his foot from the footpad onto the surface. So in a way, it really was an accurate description. When he says one small step, he's only taking his left foot and moving it off the footpad. But yeah, coming down the ladder, that's another story. Yeah.
Nice. All right. So this last step was small, but there were some, as we saw, there were some pretty big hectic decisions and steps that had to be made. So another question a lot of people had is kind of a combination of how many times did we go to the moon? Or was it the same procedure each time? I think Chris mentioned at the beginning that we stopped going in about 1972. So why did we stop? And can you tell us a little bit about, sounds like we're going back. Can you tell us about that? So how many times did we go? Why did we stop going? And what do we know about going back soon?
Okay, so the rest of us start with the first question. How many times did we go to the moon? This is a little bit of a funny question because depending on what you mean, it could be a different answer. So I'll start with how many times did a human spacecraft go to the moon? And the answer to that is 9 times. We went to the moon 9 times, didn't land 9 times, but we went to the moon and either slingshotted around in the case of Apollo 13 or orbited in the case of Apollo 10 or 8 and all the rest of them. Now, 9 times we go to the moon, we only landed 6 times because Apollo 13 could not land. But 13 did go around the moon. Now, out of those 6 times, we spread across the near side of the moon, more or less centered on the equator, although 16 and 17 were dispersed north and south of the equator. 11, 12, and 14 were almost right on the equator. So we landed the last time with Apollo 17 in December of 72. Now, the question of why we did not go any further beyond that, why we didn't go back, that all has to do with 2 things, and they're both connected. One, the will of the American people had been satisfied by us landing, bringing back rocks, beating the Russians. So NASA got its budget cut. We could no longer afford to keep going to the moon. That is really the honest truth. So it's very, very expensive to go to the moon. It's about $25 billion in 60s money. So you can imagine what that would be in today's money. So the last time was in 72. NASA and SpaceX are both planning to put boots back on the moon in 2024, but don't hold your breath because NASA's budget still has not been fully approved. It may not take place right then, but that's their goal. So 2024, both NASA and SpaceX plan to put boots on the moon. They are planning to land at the lunar South Pole or near it. And there's a good reason for that. Water ice in some of those craters down there will provide some life support supplies there. So that's the, I guess, the latest update without giving details because we just don't know how that's going to pan out with this time schedule. But that's the idea.
That was a really amazing and thorough answer. So it's exciting to know that we may be going back pretty soon. I would imagine that we've figured out some newer technologies to maybe even we stuck the landing so well the first time, but it'll be fascinating to see what kind of new technology makes the trip all that much easier. Which leads to, I think we got time for one last question. The topic on everyone's mind. We saw that your museum is built to look like a moon base. The idea that regular people, you don't have to be an absolute genius and totally cool under pressure like Mike Neal and Buzz to be able to get there. When do you think regular people, or do you think regular people will have the opportunity to visit the moon, to see some of the landing gear that was left behind, all those kind of things? What do you think? Are regular people like us going to the moon anytime soon?
I don't think so. And only because of the money issue. I think people who are filthy rich, millionaires, multimillionaires might be able to participate in some of that. As to the second part, will people be able to go back to some of those original landing sites? That's going to depend on the mission profiles. That is what people intend to accomplish, because it's going to be expensive no matter where you go on the moon. But to put people like you or I on the moon, I don't see that happening anytime soon, simply because of the cost. The cost is really, really almost prohibitive for anybody but somebody sponsored by a government or a massive company like SpaceX. So yeah, I don't want to put the damper on it for some people, but I don't know that that's really a realistic thing for average people, at least not in the near future.
I think that leads to a pretty good challenge here for everybody out there. Choose to be excellent. If you're ordinary, you're probably not going to get that opportunity. But at one time, Buzz Aldrin, Neil Armstrong, they were in shoes like yours, learning, right, middle school, high school, math and science, tinkering, and and aspiring to learn as much as they can, to try new things. So the opportunity is still there for many people to go to the moon, but you probably have to be kind of exceptional to do it. So that's why paying attention in science and math classes, learning as much as you can, including maybe checking out that biography of Neil Armstrong that you could win as part of the contest here, joining Varsity Tutors for Space Camp, and all kinds of other learning explorations and expeditions are maybe the key to punching your ticket for the moon. So, hey, Greg, thanks so much. I know Chris was there right off screen there. A huge thanks to you guys for this class. You referenced the one we did on Gemini missions, a couple months ago. Huge thanks. These are always so educational and just really fun and enjoyable. Thanks to all of you out there for all of your questions. We always get really excited to go check out all those selfies on Instagram afterwards. So with that said, let's make sure everybody knows those instructions to be able to post those pictures and have a chance to win. We'll see you all back here very soon for more classes on space and other topics. And we hope everybody had a blast. I know I did, and we'll see everybody soon.
Thank you, Brian.